Okay, guys, I'm going to try to knock this out during my lunchtime, and I'll go through these as quickly as possible. First one I'm going to start with, this is, just so you know, this is, I'm making sure I'm on select. Whoops, that's not what I wanted to do. This is 6.2, and this is non-unit circle working with sum and difference equations. So I want you to see that all these sum and difference equations down here are exactly the same sum and difference that we've been working with the unit circle. But before I get started on that, I want to go back to this. So if you have sine theta is equal to, that is negative 2/5, then that means sine is negative in these two quadrants. Remember, all stairs take caution. And this is where all things are positive, sine's positive, tangent's positive, cosine's positive, according to the all stairs take caution. So if you can remember those letters, that's going to help you. All right, so sine is negative in the third and fourth quadrant, and tangent is negative. Tangent's negative where sine is positive and cosine is positive. So we got two checks in the fourth quadrant. So remembering that the angle has to come from the origin, this is supposed to be a right triangle, I get negative 2/5. All right. So if I do the Pythagorean theorem, 5 squared equals a squared plus b squared. Whoops, I clicked on something and didn't mean to. 2 squared. That's going to give me 25 minus 4, which is 21, and that's a squared. So a is the square root of 21. All right, so now that I have that, I can go back and I can find the sine, cosine, and tangent. It gave me this answer in the setup of the problem, so if I miss it, well, my name's going to be Mud. And I'm dyslexic enough, my name could be Mud. All of these over here, it's just a matter of flipping them. So cosine is square root 21/5. Tangent is negative 2 over the root of 21. But it is not okay to leave a root in the denominator. We need to rationalize. So negative 2 root 21/21 is the final answer. All of these just get flipped, okay? So this one would be 5 over the root of 21. This one would be negative root 21/2. This one's good, but this one has to be rationalized. 5 root 21/21, final answer, okay? Now, the reason I wanted to do this is it's exactly how we're going to be doing these problems down below. We're still going to use all of these formulas, so I'm going to scoot it up as much as I can, and I'm going to show you how to do this one. Now, it says for the following, sine of A is this, cosine is B, cosine of B is this. It doesn't tell us what quadrant, so assume the first quadrant, because it's just saying for some triangle where this is true. So we're going to assume first quadrant for both of these. And so sine of A, this is angle A. This one is angle B. Okay, sine of angle A is 5/13. Do the Pythagorean theorem. And I'm not going to take the time to do this. You can do it and see that this is a Pythagorean triple. It really is. Cosine is 4/5. When 5 is the hypotenuse, this is a 3-4-5 triangle, as long as I have a 3 or a 4 on one of the legs. All right, so if I want to find cosine of A plus B, I have to do cosine of A. Now, I had my kids do this in class without me helping them, but the minute I did that, they just found the cosine of A, cosine of B, and thought they could add them together. You can't do that. It's cosine of A, cosine of B, minus sine of A, sine of B. They thought all of a sudden, now we don't need to use the rules anymore. No, that's the whole reason why I had the rules up here to begin with. All right, so when we fill this in, we find sine of A. I'm going to go back. Here's A. Sine of A is 5/13. Cosine of A is equal to 12 over 13. So if I start with cosine of A, I need 12 over 13. And so then the sine of A is 5 over 13. But now it's asking me for B. Ah, shoot. That means I got to go over here and I have to say, well, sine of A is 3 over 5. Cosine of A is 4 over 5. All right, so now I've got cosine is 4 over 5. Sine is 3 over 5. Okay, if I add these together, notice that denominator is going to be 65. This one's going to be 48. This one's going to be 15. So 48 minus 15, 33. And that is right. Then you're going to find number 2, sine of A plus B. Okay, so in this one, I have to do sine of A cosine of B plus cosine of B, cosine of A, excuse me, sine B. I really do know these, I promise I do. All right, so sine of A gives me 5 over 13. Cosine of B gives me 4 over 5 plus cosine of A, 12 over 13. Sine of B, 3 over 5. Okay, so if I don't get the same denominator, I messed up somewhere. Do not simplify. I realize that right here, we have 2 5s that you're thinking, oh, I could reduce those. Don't do it, because what I'm trying to get to is addition, and I have to have a common denominator. So resist the urge. Don't multiply. Don't reduce that. What you do want to do is get 20 here and get 36 here. That's a total of 56 over 65. You got that same denominator of 65 in both of them, okay? That's because they had the same hypotenuse that was used in each of them. Now, tangent is a totally different bear. Tangent is 1 plus, I'm going to do it up here so I have a little bit more room. 1 plus, no, it's not. It's tangent of A, sorry. Tangent of A plus tangent of B all over, this is what I was thinking, 1 minus tangent A, tangent B. It's multiplied. Okay, so that means I have to go back and I have to find tangent of this guy. Tangent of A is 5 over 12. Tangent of, whoops, that is a 12. I said it, didn't write it, and you can't see the 1. Tangent of B, oh, and these were all B's. That was cute. I just noticed it. All right, tangent of B is 3 over 4. So tangent A is 5/12 plus 3/4 all over 1 minus 5/12 times 3/4. And that looks like a 14. I don't know what I was thinking. 3/4. Okay, so I'm going to simplify the top. To simplify the top, I need to multiply this by 3 over 3 to get 12ths. All right, that's going to give me 5 plus 9 over 12, which is 14 over 12. All right, then I'm going to do the other set of fractions. This one I do want to reduce because I'm multiplying. So when I'm multiplying on these, and then I've got an addition to take place here. If I reduce this, 3 goes into 12 4 times, and 3 goes into itself 1 time. So this means that I have 1 minus 5 over 16. That's this denominator. Well, I can't add these together yet because 1 doesn't have 16. So instead of 1, I'm going to multiply this by 16 over 16, and now I can subtract, and that gives me 11 over 16. But it should make sense. If you have a whole pizza cut into 16 pieces and 5 pieces are gone, you have 11 left. All right, so normally this would be great. Now I keep, change, flip it, which you can. But before I do, I'm going to tell you these will reduce by 2, and I would get 7/6. So now I'm going to keep, change, and I'm going to take this one and flip it. 16/11, and something really nice happens here. And if you don't look for this, your numbers are going to get big. That becomes 8. This becomes 3 because I divided by 2. Final answer, 56/33. Notice that these two answers both got 65. Sine and cosine are going to work that way. Tangent is just a different bird altogether. Don't try to draw any connections with what you have here. Let's just go with how we do this, okay? Now, let's look at the next set, because the next set has something else that happens, because I am trying to prepare you for everything, all right? So scooting this on down. All right, that's not what I want to happen. Go away. It loves to do that to me. All right, so on this one, this is for my sine of A, and it says they're both in the 4th quadrant. So sine of A is over here in quadrant 4. This is my A. And sine of A is -2/3. So with a little work with Pythagorean theorem, I should get square root of 5. Now, that means cosine of A is going to be the square root of 5/3. Do I have another cosine of A or tangent of A? Tangent of A is going to be -2 over the root of 5. So rationalizing, root 5/5. Okay, I've rationalized. If you don't know how to do that, you need to see me separate. And now we have a different story with B going on. I'm given that the measure of angle B is on the unit circle. Okay, so wait a minute. On the unit circle, -pi/3. Positive pi/3 is up here. So -pi/3 is in, just flips to down here, -pi/3, or this is located at 330 degrees, if you want the degree mark to find it. So that means I have a coordinate pair for this. It's 1/2 -√3/2. So my sine of B was not asked for, but it's -√3/2. The cosine of B is 1/2. The tangent of B is -√3 because it is sine divided by cosine. Sine over cosine. All right, so to find tangent of A, I'd like you to stop the video and see if you could do these without it, but I'm going to go on and get these done. So I have, and I don't take a shortcut on this. I write these down every time because it's very easy to make a mistake with them. So plus cosine A sine B, fill it in, sine of A. I don't think I wrote down the sine of A anywhere. Oh yeah, I did, -2/3. -2/3 cosine of B is 1/2. So guys, my denominator better be 6 plus cosine of A square root 5/3 times sine of B square root 3/2, and that's a negative. So my final answer, it's all over 6, and I'm left with -2 minus, why negative? Because there is a negative right there, making this a minus sign. And square root of 5 times square root of 3 is square root of 15. I'm done. You cannot do anything about it. Now, I pointed this out to my class today as I taught this. When I have sine of A plus B, sine of A minus B, the only thing that changed in this problem is this negative, meaning that right there would go to a negative. So I'm going to shortcut this, and I'm going to take all of this information that I had over here and write it here. So I have negative 2/3 times 1/2, but now minus square root 5/3 times negative root 3 over 2. So what's going to happen here is I get negative 2 plus the root of 15 all over 6, and there was very little change. I took a major shortcut there. Number 7, it's cosine, so you have to do cosine, cosine, plus sine, sine. I'm going to leave that one for you to work. And I tell you, the answer will come out again. It will be some fraction with a 6 in the denominator, okay? I want to get on to tangent so that this video is not too long. And this one's really ugly, so I want to show you all of this work. So this one's going to be tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. So the tangent of A is going to give me negative 2 root 5 over 5 plus negative root 3 all over 1 minus negative 2 root 5 over 5 times negative root 3. All right, I'm going to simplify the top, then simplify the bottom. On the top, all I have to do to simplify this is multiply it by 5 over 5. Normally, this 5 goes up here in the front, but my negative's kind of in the way. So I will tell you what comes out of this is negative 2 root 5 minus 3 root 5, minus 5 root 3, excuse me, minus 5 root 3 all over 5. Then the denominator for this one, all over. Now, this one needs to simplify a little bit in here. This is going to go over 1, and I'm going to be left with just a straight up multiplication. So when I multiply this, I'm going to get 1 minus the double negative is going to make this turn into a positive. So I'm left with 2 root 15 over 5. Now, to combine this, this needs to have a common denominator, 5 over 5. So my final answer for this one is going to be 5 minus 2 root 15 all over 5. If you're looking at this going, holy Toledo, that's crazy. Number 1, I showed you in the class what to do about it. Number 2, since they both have a 5 in the denominator, you can reduce that 5, and the final answer is negative 2 root 5 minus 5 root 3 all over 5 minus 2 root 15. Now, I'm going to be the first to tell you, this is not fun to rationalize. I would accept this answer. I will not count off for not being able to rationalize that. That's not an easy one. And that gets you through to the homework. So have a good night, and I hope this is helpful.